Hey, ladies and gentlemen, welcome to section 6.3. This deals with multiplications and exponents. We got a couple different rules that we need to know. We're talking about here the multiplication property of exponents here. We'll talk about this at length in this lesson and in class, and then the power property of exponents. Okay, and so make sure you get these examples written down. We're going to go through some stuff here together and talk about that material as well. Okay, so multiplication property of exponents says when we have values like x to the fourth, we're multiplying it by x to the third. As long as the bases are the same, in this case we both have x's, our exponents then we add together, so we end up with an answer of 7. Okay, so we take 4 plus 3, we end up with x to the 7th. That means, if you think about it, this is x to the fourth, that's 4 x's. This is 3 x's, so we end up with 7 x's. Okay, so now a little bit of a more challenging example, 4x to the third times 3x squared. Here, our big numbers, the 4 and the 3 here, we multiply those together because it is a multiplication problem. So we end up with 4 times 3, and that gives us 12. Okay, so we break that problem up that way. Now we have our x to the third and our x squared. We add our exponents together there. We end up with x to the fifth. Okay, so the big numbers we're going to multiply together. We multiply, and then these small ones we add. Okay, and in this last example, we have a combination of a whole bunch of different things going on. We've got x to the third, y to the fifth. We multiply that by 3x squared y. Alright, so we need to break this problem down into some different parts. So here we've got only one big number. So that means our big number here is just going to be 3. We have x to the third and x squared. So we have x to the third times x squared. That's going to give us x to the fifth. So we have x to the fifth in our answer. We also have y to the fifth and y. Okay, so we have y to the fifth and we have y. Now this is where people kind of get some, screwed up here. There's 5 y's here plus another y, that's y to the sixth. Okay, this is like an exponent of 1. We don't usually write exponents of 1, so we end up with y to the sixth. We gotta make sure we make special note of that. Okay, so 3x to the fifth, y to the sixth ends up being our final answer there. Okay, so that's multiplication property of exponents. Now here is a little bit different. This is what we call a power raised to the power. We have x to the third, and we're raising that to the fourth. Okay, so here what this is saying, this is x to the third times x to the third times x to the third times x to the third. That's what this to the fourth is telling us. So if we look here, we have 3, 6, 9, 12. We have x to the 12th. Okay. Now, unfortunately, or not unfortunately, luckily for us, we have a shortcut. What we do here is if anything that's a power raised to a power, we take and we multiply our powers. So in this case, we take 3 times 4, and that would give us 12. Okay, so now we look at this next problem. We have x, y, and that's raised to the fifth. So now this goes back to what we had with our previous example. These are both raised to the first powers. So we would take 5 times the 1, that gives us x to the fifth. We got to take the 5 times the other one, that gives us y to the fifth. Okay, and so this would give us this answer there. All right, now here is the last tricky aspect that we're going to deal with. 3x squared, that's raised to the third power. Okay, so we know how to handle x squared raised to the third power. We know that's going to be x to the sixth. Okay, but now if we think about this in terms of expanded form, we have 3x squared, and that's 3x squared and 3x squared. Okay, this is what it is, expanded form. This is how we got the sixth power. We talked about that before. But now we look at how many 3's are there? Well, there are 3, so we're taking 3 times 3 times 3. Do you see that we can take the 3 and we raise it to the third power? So we raise that 3 to the third power. We don't multiply them, we raise it to the third power. So what that turns out to be is 3 times 3 is 9, times 3 is a 27, and we have x to the sixth. Okay, so our little numbers we multiply here, and big numbers we treat as normal. All right, so big numbers is normal exponents. Okay, so that's what we've got here. So 27x to the 6th was our final answer. So this is multiplication property of exponents. We've got multiplication properties where we add the big numbers together when we're multiplying, and then we have the power property. We're taking it raised to another power, power to the power. We multiply our two powers together. Okay. Make sure if you have any questions, you let me know. Have a good day.